So tuple space communication is a shared memory approach. Shared memory approach for indirect communication. Okay. Now, basically, what happens in shared memory? Data is kept in shared memory and multiple processes can access it. The same thing here we are talking about, that we will keep the data in a shared memory and multiple processes can access it. What we are talking about, or what it was proposed by David Galanter, okay, nice name it was, let me write it, it was David Galer, NTER. So he proposed about this tuple space. Now what they are talking about is that this is a space, suppose it is a shared memory. So rather than keeping the data here, when we keep a data, it is just a stream of bytes, right? So in place of keeping a stream of bytes, it is better to keep the data in a particular format. Okay, so it may be in a particular format. Suppose it will have certain information, suppose Kamal 1980. So in this way it can be treated as one tuple. One tuple or one record, you can also understand. Record is more familiar to you. So this is one record or one tuple. So now other thing is also that this is not that it has to follow the same format, that the first thing will be a string, another will be integer. No, that is not like that. In another tuple you may have 3 different values. That is also a tuple, and all these tuples are allowed to be stored in this particular tuple space or shared memory. So which is connected, multiple processes may be connected to it. So multiple processes, these processes can access this data. Some processes are storing the information, the same processes or other processes may be accessing the data, maybe updating the data. These all possibility is there. Okay, so here there are actually 3 different operations I should name. One operation is write operation, you can understand. Write operation is an operation which is for inserting a data, okay, inserting a tuple. Okay, this is just inserting a table, no problem. Now there is something called updation, but I will tell you how updations take place here in tuple space. Before that, let me tell you other 2 operations. One is read operation. When you want to access the data for whatever reading, for just reading operation, read operation. So this is write operation, this is read operation. One more operation there it is, we call it take operation. Okay, so what read operation does, we will give certain thing with the read command. We will tell what type of record, what type of tuple we want. So it will find the tuple and return it to us. So let me write it. It returns tuples matching constraints or conditions or rules, whatever is specified, है ना, constraints. Take command is also returning the same thing. Returns the tuple, also deletes it, I should say removes it, removes the tuple from tuple space. Anything that you want to ask, please go ahead. So if you want to implement these operations, write, read or take operation, suppose let us take an example which is given in the book. This is your tuple space. You have stored some information like capital of Scotland is Edinburgh. Okay, you have capital of India is New Delhi. Okay, suppose you can store population of India is some number, 128000 something, whatever. Let me write 2 more zeros. Okay. Similarly, some more there maybe. I don't make it bigger. So, for writing a new record, you may write it as, there can be a write command with certain argument. What it will be? One tuple which you want to store. You want to store population of China is suppose 21000000, whatever. So if you will write such command, this particular tuple will be inserted in the tuple space. Okay. If you want to read something, for reading you will have to give certain command. You will specify, suppose you are specifying the first thing should be a string, second thing should also be a string, and third thing, what do you want it to be, a string or an integer? Tell me something, string or integer?
String.
Okay. So if you like keep like this, you want to read a tuple or the tuples which match this pattern, string, comma string, comma string, which should have 3 values, each of which should be a string. I believe if such command is given, then these 2 tuples will qualify a string, a string, a string, and they will be returned. What do you think? So let me take it. In this take operation, what will happen? You will write something like take. If you will write string, then it will read all these string, return these strings, and remove these strings from the tuple space. Okay. However, if you will write something like take population string integer, in that case those tuples whose first column is population, if this has been written already, then the two tuples or maybe one tuple only, let it be, those tuples where population is there, those tuples will be removed and returned. Okay, so these things may happen. So here also you can understand it is totally a space uncoupled, okay, and also time uncoupled. Do you understand? A space uncoupled, how? The processes which are writing the data and the reading data, they should not, okay, means they should not know each other. Anyone can read, anyone can write. And time uncoupled, they should not be present at the same time. Okay, one will write at a time and the others can read at any other time. Okay. Now, if you want to see a little more detail how actually it will be implemented, suppose you want to see how write operation is done. Okay, I was telling you about update operation, right? So what happened in update operation? In update operation, first of all, you will take the record, take the tuple. It will return the tuple and remove from the tuple space, and then you will write again the new tuple. In this way, you will update the tuple in tuple space. So, write operation. Okay, what I was telling you, in distributed system, one thing basically what we do is, if at all we try to keep, I should say, take care of failures. We say that in centralized system, what happens, the data, if the server crashes, then services are not available anymore. So let us have a system which is not non-failure, or means it can deal with the failures till a certain extent. So how to work with a system where we want it to be a fault tolerant system? Basically, one way for fault tolerant we wanted, we have seen earlier also, it is replication. What do we do in replication? We replicate the data, or services across servers. Okay, or let me not servers, nodes. So because of this, Now now for just being a fault tolerant system, we want to keep the data in a replicated manner, which is definitely giving us a service that it will be fault tolerant. However, it will also make the system a little complex. Okay, little complex. What is happening now? Your data is replicated. Suppose this was your data, so it is not only present on this system, this node, it is also present at other places. Okay, it is present at other places for giving a better service. Okay, it may be the reason of giving better service to the clients on a different location, or it may be for the reason of making it fault tolerant. But somehow, suppose this thing is kept on a separate node, replicated on a separate nodes. In that case, if you want to perform certain operation, then what will happen? First thing was, suppose I am saying write operation. If you want to insert a new record, I believe it may not create that much problem. What do you think? The request may come from this side or request may come from this side. It is just inserting operation. So here you are trying to insert. It is being inserted at this place. So this will make a multicast information sharing to all the replicas. Okay. And your new insertion is inserted in all the replicas. Done. This was the case of write operation. Okay, not easily done. It will keep on sending this information to all these replicas until they get a positive acknowledgement. They need an acknowledgement of this thing, that they have received this thing information. This was the story of write operation. What is the story of read operation? It is not a big thing. You have just to read it. If at all it is available here, you will read it. So maybe suppose it comes to a node where this data is not here, data is on another nodes. So this particular data we want to read on this side. So it sends a multicast this thing request to all the replicas, keeping in mind that whichever replica gives the results first, that is okay. So it sends it, and whichever the first result it gets, the tuples, it accepts it and shows the result. And after that, it doesn't send any request to these others. However, until it receives the first result from any of the replica, it keeps on sending the request to all the replica. So that is the case of read. Take operation is something that we have to keep in mind. Actually, in take operation, what we do, we read the information, read the tuple, and also delete it. And when we are deleting the record, we have to delete it from all the replicas. So in that case, what we do, we send a request, multicast request to all of them. Okay, so I should say it is in two phases. In phase 1, it will send a multicast request to all of them. So when it is sending a request, then these replicas will lock that particular data or tuple that we have to delete it. but it does not delete in this phase 1. All of these replica locks it and sends a reply to this particular requester that okay, we all have locked the data for deletion, or you want to take, so that is the thing. So once it has the information that all of they are ready, then it can start the phase 2. It will send a remove request for this particular tuple, and they will remove these tuples from their replica, from all the replica, and also they will acknowledge that we have removed. So in this way, read, write and take operations will be in the distributed systems. Anything that you want to ask, please go ahead.